Hello! If you watch my channel, you'll know that I was recently working on this. It's a huge JVC professional video recorder that takes these metal formula tapes. So it's very broadly based on VHS, but it's totally incompatible. And this machine was something I collected on a road trip, and it was supposed to work, and it did work for a fleeting second and then broke down. And if you watched to the very end of my video recently, you'll have seen that I put it through a self-test, and you can actually do a test without even having a tape in it, and it showed that the take-up spool is not working. Let's just prove that again, and let's see if there's anything we can do to try to pin down whether it's a bad motor or drive electronics. Okay, so I'll switch this thing on, and we can go into a menu setting. Oh, it's in diagnosis already. Okay, so I don't need to go into the menu setting because I've left it in do diagnosis test at switch on, and it does a sequence of tests. One of them involves spinning both supplies and take-up spools, but it says that the take-up spool is not spinning. If I spin it by hand, the error goes away. Let's just show you that again. If I spin the right-hand spool during these tests, then instead of coming up with the error message, it'll just exit the diagnosis test. So it's laced up, it'll unlace, and because I'm spinning this frantically with my hand, it sees movement and it will just exit, so it's passed. That's what it should do without me having to frantically spin the spool. Okay, access from the top does not look good. It's not clear to me if you have to take the deck out in order to gain access to the underside of the deck, but it doesn't look that accessible. Having removed a big metal panel from underneath, access underneath the deck doesn't look very good either. And this, I think, is the problem with JVC and Panasonic professional equipment. Access and serviceability wasn't considered to be a top priority in the way that it is with Sony equipment. So when it breaks down, it may not be that much fun to fix. That's annoying. I really need to get to the underside of the deck. I can see, for example, the capstan motor is just there, big flat motor. That's, something I can see, but I can't see the real motors. Oh, what do I do? Do I have to take these boards off? Okay, that sort of swivels out the way, so that's somewhat better access to the deck underneath, but still not to the bit I need to get to, which is under here. So there's the head motor, and that's the capstan motor. Okay, I'll prop the door open with a cassette, Betamax of course, only the best, and see if we can gain some access if I take this board out. Well, no, access is almost impossible, but all I can see is the cables from this board go onto this metal panel, which is where the two real motors are mounted, which means this board drives the real motors, and it's got two sort of drive circuits here. So these cables here go out to the real motors. Perhaps I'd better check that these resistors, which look like fusible resistors to me, have not failed. I'm just going to try and put the board back into place roughly. They may or may not be fusible resistors, but anyway, they are certainly, I think, associated with this circuitry. So we should have 0.56 ohms across each. It says 0.6, 0.6. Okay, what I can do is put it into its self-test mode and see what voltages appear on these resistors. Let's do that. Make sure this isn't shorting to anything. So if I power it up, it should go into its self-test. Okay, it wasn't ideal having the cassette in there. We've got no voltage on one of them. I'll have to do that sequence again because I was put off by things rubbing that shouldn't have been. So no real voltage on one of them. But 0.7 volts. It might be on the earthy side of the motor though. So 0.08 volts on the top end of one of them and 0.08 volts on the other one. Okay, I don't have schematics for this thing as far as I'm aware, but let's see if I can find something. Right, I've been looking up the schematics and they're not that clear, but it is... One thing that's unfortunate is I cannot swap the supply and take-up motor connections around because the wiring is completely different on the two motor supplies, and one of them's got a feed to the lamp, as it puts it, which is the LED sensor, told it's based sort of on VHS, and the other one's got a feed out to a solenoid. So we can't swap them, but what I can do is compare the incoming signals to the driver chips, see that we're getting the correct, that we're getting information to the driver chip to drive the motor. The driver chips are here. This is IC4, this is take up, this is our faulty side, and this is supply, which is working. And the fault is either on this board or on the motor. I can't easily test the motor at the moment, so let's test the board. Right, so we'll look at just the supply side for a moment, pin 1, because we know this works. And what I believe pin 1 is, it says supply error. I think this doesn't mean error. It means the error signal. In other words, it's a voltage, a feedback voltage to tell the motor to speed up. So we should see that rise and then come down as the motor speeds up. So let's switch it on and see what we see on the working one, which is the supply side. It's in diag. The supply motor is spinning. If I slow it down, I wanted to see that voltage go up. I'll do it again. This time I'll slow the motor down with my finger and we should see the supply error go up. So the motor's spinning. If I slow it with my finger, it doesn't really do a lot. I was expecting to see a much bigger voltage on that. Let's put it into auto range. Do that again. So we're looking at the supply motor on the meter. So it's going up to a small voltage, and if I slow the motor down with my finger, it doesn't alter. Okay, bit unconvincing. There's a forward control, which I think just tells it the direction to spin in, so that won't be so exciting, but let's see that. That blipped up. Very small voltages though. What about the supply stop signal? So that's at 5 volts now, which presumably means stop. So let's start it. It's at 5 volts. Then presumably when the motor starts spinning, yeah, that goes away. Right. So that's telling the motor to spin. And then when the motor does stop, there we go. That goes up to 5 volt. 5 volt while the motor's stationary. Now the motor's spinning. Motor's spinning, 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 spinning. It's still spinning, but I think it's slowing. Odd, it seems that the stop signal arrives quite a long time before it actually stops. Right, let's have a look now at the take-up, which is the faulty side. We'll start with take-up stop, which is one we were just looking at a moment ago. So it's high, which means please stop. And now it's come off, which means please go, but it's not going. And then it goes high, which means stop again. Right. So the take-up stop signal looks sensible. Pin 7 is the take-up forward control, which I think is just direction. That's gone up to 5 volts, which I think means go forwards probably. So I don't see a fault there. I think that's sensible. Whereas the other one, you didn't see 5 volts there because the motor's spinning backwards. That seems sensible. So now the take-up error, which is on pin 5. Let's see if we get a signal on here, but we didn't get an awful lot on the other one. Just millivolts really. Well, we're getting millivolts on this one too. So from what I can see, this board is getting what appear to be correct signals to both motors. Now the outputs are, somewhat to my surprise, these three, the coil signals. So let's compare the coil signals for the take-up side, which are not working, compared to the coil signals for the supply side that is working. I may need to hook an oscilloscope up for this. Okay, looking at the supply side, pin 7 of CN5, that's one of the coils, we should see the coil being driven for that motor. Oh yeah, you can see it spinning up. Okay, so that's driving the coils for that motor. Now let's look at the same one, that's coil 3 on CN7 pin 3. Okay, so let's see if it attempts to drive it. Trouble is, it's hard to tell with motors what's cause and effect, but let's see what we get. Well, nothing convincing. But of course, with no feedback from the coils that are coming back, that's supposed to go into the op amps of the driver chip, it's a little difficult to tell what's cause and effect. It could be the driver chips at fault, or it could be the motors at fault. It's a little difficult to tell. When I turn the motor by hand, see, things happen. See, if I turn the motor, it moves. And because I turn the motor, it's not shut down in fault condition now. So it's very hard to tell, isn't it, if we are failing to drive the motor or if the motor is failing to work. We'll check we have 5 volts out on the motor, but I'm sure we do. because it's the same 5 volts shared between the two motors. But we'll just double check that. So looking at CN7 pin 3, which is one of the coil outputs for the real motor, it just seems to go high, and if I turn the motor it moves. Look, it moves when I turn the motor. See? That's definitely an output, not an input. It does feel like an input, but it is an output apparently. That's the difficult thing, isn't it? Working out what's cause and effect. Because turning the motor alters those coil signals, but they're supposed to be outputs to the motor. Look, if I turn it, it moves. If it stops, the signal stops. But that could just be because I'm turning a motor which has got magnets against the coil and the chip is just not driving it. That could well be the problem. It could well be failure of this IC. Let's check that we have 5 volts out to the motor on its pin 4 of that same connector. 1, 2, 3, 4. We should have 5 volts all the time, I think. Yes, we do. It says to me, I think the fault is the driver chip. I don't think it's the motor. And I'm sure we have 5 volts on the motor. It's on the driver chip. It's on pin 13. R24, top end of that should be 5 volts. I'm sure it will be. Yes. Well, a little under 5. Let's try something out of desperation. Let's freeze IC4. An inverted air ducter acts as a fairly good freezer, so I'll do that. Okay, that's really cooled down IC4. No, that didn't help at all. Okay, I think my only reasonable guess is that the problem is IC4 itself. I have nothing else I can try. The other day I collected this. It's a JVC D9, also known as digital S format machine. Takes tapes that look like VHS, but they're not. It's actually a metal formulation tape and records digitally onto it. Professional format. And I got this from a collection where I collected lots of different machines. I put it in the workshop, switched it on, it worked momentarily off camera, and then immediately broke down. The take-up motor is not spinning, and I think it's the driver chip on a board underneath that's failed. But they're extremely hard to get. There's no one in the UK sells
Special delivery.
Oh, maybe I can fix it now. Okay, so this, I've got 2. This is the chip which I hope will fix it. AN3834K, and it's designed purely for driving real motors. So it wasn't a very popular chip because not many video recorders have twin reel motors of this sort of design anyway. Right, so I got the video recorder off the pile where it was stored, and immediately some plastic fell off it. In fact, it fell into 2 pieces, so I think this plastic's gone brittle. So what I'm going to do for now is just sticky tape this back into place, and if and when we fix the machine I'll glue that up later, but I don't want to glue it now because the lid's going to have to come off a few more times. Right, now a nice feature of this machine is you can set it into a self-test when you switch it on mode, diag mode, and I've done that. So let's plug it all in and we'll show that it fails to complete that test. And it will, you'll hear some various clicking as it tests all the motors. So it's in diag mode. and it's going to auto off. If it passes the test, it doesn't do auto off. Let's take the cabinet off the top. So this is the take-up spool, and that's the one that's not been spinning during the test sequence. And I can show you that again. So you'll see it test. The head drum spun for a moment. The supply spool is spinning in reverse. It will lace up, but at no point is this rotating, and that's because that motor is bad. Or the motor drive is bad, and it's gone into auto off error mode. Okay. Now, because of the way it's constructed underneath, it's not possible for me to swap the wiring over to prove that the motor is not at fault, but I seriously doubt the motor itself is at fault. And I have some good reasons for that. One is that I worked out what the various windings are on the motor, and I was able to show that it was getting pulses back when I turn it from the coils that are supposed to detect the motion. So that is proven to be working. But I also showed that when I turned it, I was getting pulses back from the coils that are supposed to be driven by the chip that were being fed back. So that shows that none of the coils have gone open circuit. So if none of the supply coils have gone open circuit and none of the position coils have gone open circuit and it spins freely, it's not the motor. Unless there's an extremely obscure fault gone on, it's not likely to be the motor. So it's going to be the drive electronics. Right, so let's have a look at the drive electronics again. This is not the drive board. We need to move that one out of the way. Here's our driver board here. And the chip in question is this one. So that one was okay and this one was defective. I'm considering if I unplug all the cables, can I take the whole board out and work on it away from the machine? I think that would be preferable to trying to replace the chip with it hanging in the machine. These connectors here could go into the wrong sockets. There's nothing to stop that from happening. Right, I think I'll take the machine off the bench to give us all the space we need to do this work. We have take up, which is the right hand motor, connected to IC4, which is confirmed as that one there, IC4. So IC3 supply, and that's all working. You can't swap the connectors around for the motors because they are wired with a different pin out, and they have some different functions. There's other deck related components plugged into the same connectors. So we have to do this. You know, it'd be really nice if these went straight to the motors and we could have swapped it over and the other motor would have spun and we'd proven that the board was at fault, but it just wasn't an option. Right, so what I'm going to do, I've got to desolder this chip. I will set you up on a microscope so you can see that. It's a double-sided board, so it's going to be the old thing. Do we use a desolder pump or do we use a desolder braid? And I usually start with desolder braid and see how that goes. Here's our replacement parts. So we'll just check that looks the same when we've taken the heatsink off the top. Is there going to be some heatsink compound in there? Yes, just a smidgen. And there it is. Very similar date code as well. Very similar part. So we've got the fun of taking this part out of here. Let's take a closer look under the microscope. So here's the part we're going to be changing. As you see, it's soldered both sides, so this isn't going to be particularly easy. Quite small connectors too. So let's start with desolder braid. This isn't conformal coated, is it? There's a distinct shine to this board.
That would make it harder, wouldn't it? I mean, in the end, if I have to, I can just cut the leads. You know, if we get desperate enough, I'll just cut the pins off. But I'd rather not. All right, Chemtronics, Chemwick. I don't even remember where I bought this from, but I'm really glad I did, because it's the best desolder braid I've ever owned. It really, I mean, it's solder wick. It really sucks the solder out. So hopefully that will do the job. I'm going to start by adding fresh solder to the pins. And we'll get a feel for whether there's conformal coated at that point as well. I don't know if there's coating on there or not, but I'm managing to solder okay. It looks fairly desoldered from the bottom, although I can see a little shard of solder. Ouch! It's still quite hot. Judging by how grotty the board's getting, yes, it does have a coating on it, which is now getting damaged by the desoldering process. And how are we doing in terms of clearing the holes? Some success, but not all of them. Can I get my soldering iron into the top? Maybe, maybe not. I think I've got rid of most of the solder, but not necessarily all of it, so it's still going to be tricky. Okay, those where I've not cleared the solder, I think I'm going to have to resolder them. I have to say, I don't think they're clear. I don't think they're clear enough. Okay, I've done what I can with the desolder braid, but I don't think it's ready to come off. I'm going to try pushing on the IC, which I have the benefit of being able to do from the top, because I can just push on the board. I can push through the board, can't I, here? You wouldn't normally have that option. I could really use a helper to push on the other side. Well, it's not coming off at all. So, do I use a hot air gun and heat lots of pins at once and push? Maybe that's an idea. Let's try that. We don't have any surface mount components to blow off, so that might be an idea. Sort of working, but I think the board's also suffering. I think we might have got there more or less. I think we're there. Right, the chip's off. I won't go anywhere near that, it'd be very hot. Have the pads suffered? No, looks good. Got one blocked pad, we can soon fix that. And we've got a slightly delaminated bit of board there, so this bit here is kind of puffed up. Don't think that matters. Okay, so it's not beautiful because the conformal coating's burnt up a bit, I think, on the bottom. The top side's looking pretty good. Happy with that. Also, I think the hot air gun has made a bit of a mess of some of the soldering on a few adjacent components, so I'll just whip round and resolder those, and then we'll fit the new part. Okay, here's our new part, and there's pin 1 clearly marked in the corner. I think a few more of the holes are blocked, so I'll have to clear those before we can fit the part.
Well, I've been busy trying to clear out the holes here. Some of them have got a bit of gunge in them. So when I came to refit the new IC, I had a bit of trouble. I think I can now push it in fully. Right, okay, it's fully seated now. So that's good. But yeah, it was quite hard clearing these out. What I was doing was using this dentist pick and putting it into the holes and then heating it with the soldering iron to try to clean out or heat up any of the black gunge that got in there. And I think it was remnants from the conformal coating, and I've had a lot of trouble cleaning that up. I've had to clean it up from all around the board, because if it is conductive, that could be carbon, it could be conductive, it could mess up the circuit. I know it's not likely to be hypersensitive, but nonetheless. There's a little bit of damage to the board in places due to the heat I had to use. So, well, there we go, but that won't matter. A few more connections I should resolder there. So we're almost ready to fit the new IC. I say new. Look, let's have a look at them. These are the replacement chips we've been sent very kindly, and they're dated 526. But look at the condition of the metal on the top, where it connects to the heatsink. It doesn't look that good. And look at the other part here. So looking at the pins, do they look like they're brand new? Well, I might have offered this one up to the board, so that scratch there might have been my fault. But do you think these have been soldered and desoldered? Do you think this is a used part? Or do you think that it's just, a bit of storage damage? I don't know. They might be salvaged parts, but beggars can't be choosers. So this is the one that came out, which has got the different date code. Yeah, I don't know. I mean, that's definitely our, that's our old one for sure. You can see the soldering there. I've not got them mixed up. And we've got it inserted the correct way round. Pin 1 there. And the top of the board looks really clean and tidy. That's fine. So I think we're ready to solder this part in. Well, actually, no. What I should do is I should do the heatsink compound and clean this up, put the heatsink compound on, fit the screws, and then it's mechanically in the perfect spot, and then do the soldering. So let's clean this up. I've used a lot of cotton buds up on this job. Okay, so thermal grease, it says. Now the key is to not use too much of this stuff. It's only there. Oh, that's not gone very well. I'll do that again. It's gone a bit. I don't like that. It looks like it's separated out slightly. It's only there to fill in the undulations between the surfaces. It doesn't look that great. I'll mix it up a bit. Right, so let's fit the screws. You can see now why it wasn't practical for me to, in trying to fault find this, to swap these two chips around, because it's just too big a job to desolder and resolder them. I've only just noticed that some of my head cleaning sticks are the same make as the desolder braid. Chemtronics. Right, let's resolder a few connections here that have been possibly slightly dry jointed by the hot air gun. Okay, we're ready to solder in the new part. I have to say, I don't know why they used conformal coating on this, and I think it's been unhelpful. Okay, I will clean all of that off with yet more cotton buds or similar, but let's have a look at the top and see what the soldering looks like on the top. My concern is that the couple of them that actually have tracks at the top, there's one there right where it says IC4, I need to make sure that is a contact, and there's a few there on the other side. So perhaps I should solder the top as well, just to be absolutely sure that we've not had any damage to the through plating. Or maybe I could just meter it. I'm sure it's fine, but I just want to be sure, absolutely certain. Yeah, I can't get the soldering iron in there, so we're going to have to... Well, I'll meter it if I can. Right, they're all good. So I'm going to clean the board a bit more, and then we can start fitting it back into the machine. I should mention that at the same time as I've been working on that D9, I've been working on this. This is a metal pipe. I bought this one secondhand on eBay. It took me months to source. It's the fuel output pipe for my 1994 Toyota Celica, and I had a heck of a job getting hold of one of these. So I'm cleaning up all the surface rust, then I'm going to go over it with rust killer, then hammerite paint to make sure no rust ever comes back on this section here, because on mine apparently this is holed and it's leaking a tiny bit of fuel, and you can smell fuel on it, and it's a pressurized tank. So some cars do that. Apparently they pressurize the tank. When you take the fuel filler off, it should make a whoosh sound, and it's not been doing that because I think the pressure's been escaping from here. So this has been a right pain to get hold of. All the ones in the scrapyards are as rusty and rotten as the one that was on the car, so it took a very long time to find one that was in the condition that would clean up, and it cost me a lot of money, £80 just for a bit of bent pipe with a couple of flanges on it. You could probably make it for that, but there we go. Right, so excuse me while I work on this as well. Okay, so here we are. We have the real motor board with the new driver chip installed for the take-up motor. We can now set about refitting it and testing it. So the top connectors here are straightforward. The bottom ones are okay because they're held sort of in place, but we have to be careful because if you plug them in the wrong places, bad things would happen. Okay, we'll put this board back as well. Okay, we'll all get to witness this at the same time. So when I switch it on, it'll go into the self-diag mode. We'll see this motor spin. We'll certainly see it lace up, but are we going to see the take-up motor spin? If so, we've fixed it. If not, we're feeling a bit unhappy because we don't know where the fault lies. So, power it up. Here goes. That's spinning. And that's not. No, it's not spinning. So we've finished with auto off flashing, which means it's failed the self-test. So after all that work, it still didn't work. And I do not know what is wrong. Oh, that's really bad, isn't it? I had fairly much convinced myself it had to be that driver chip, because all the voltages around that and the signals around that did appear to tie up with what's going on the supply side motor. The motor is being instructed to switch on. I found a signal for that, and I've proven that the coils to and from the motor appear to be okay, so a motor fault is unlikely, though not impossible to rule out at this point. So it could be that we're not getting a signal to drive this. There's some signal that's wrong and I just don't know what the correct voltages are supposed to be, or that there's a component around that circuit that's failed, but I convinced myself that the voltages looked sensible around there. So I'm a little bit stuck, and I'm beginning to think a replacement machine is in order. Well, okay, I should say, there was another of these video recorders where I collected this from. So how about I arrange for that one to get couriered here? What I could do is organise a great big box, big enough for this, and send that to the chap who has the collection of machines. Then he only has to drop the machine into the box, and courier. We can get it back again, and then of course I'll have a working machine, but I won't leave it at that. Well, hopefully I'll have a working machine. Assume that one works. Provided that doesn't have the same fault, what I'll then do is borrow the real drive board from that machine and put it into this one, and then we can at least see if the fault is somewhere on the real drive board. If it's not, it's either going to be a board that drives this, which is probably unfixable, or the motor itself, which is definitely unfixable. So I need to do that in order to sort of try to pin down the fault a little bit more. Okay, so that's going to take some weeks to arrange. In fact, quite a few weeks probably, because I won't be available for part of that time. So we'll have to come back to this a good distance off into the future and see if maybe we can get this one going. But at least, hopefully, at the end of the day, we should have a D9. Right, I'll do plenty more content on audio and video technology in the near future. Bye for now. Well, I suppose this is the walk of shame in this business, isn't it? Reassembling a piece of equipment that you tried to fix and didn't succeed in fixing, and having to put it to one side. You can't win them all. The rust killer's not arrived yet, but I'm beginning to think I've done such a good job of cleaning this up that a rust killer may not really be necessary. I've been through it with a microscope, looking for even tiniest dot of rust anywhere along the metal here, and there isn't any left, just some pitting in the surface. So this goes from the bottom of the fuel tank and is the fuel outlet pipe from the fuel tank, and this came out of manufacture some years ago and is very hard to obtain, so at last I can get my Celica fixed. Okay, the rust killer's arrived. This is one I've been specifically recommended by someone in trade. It's not cheap, but Hydrate 80 is apparently the best. So I've already worked very hard on rust removal of this part, and it might be that really I'm already there. That, you know, what do you think? There's no rust left, is there? But this will kill off any that still exists. So having read the instructions, it says first thing to do is make sure that it's completely degreased. So we'll do that with isopropyl alcohol. And then it says you brush it on. Well, I don't have a brush of the right sort of size, so I'm going to use cotton buds. So it says pour some into a non-metallic container, having shook well, and do not pour any excess back. So this is a small piece of plastic packaging. It's a sort of white milky colour, almost looks like paint actually. And if there is any rust, apparently it will dramatically change the colour from rust colour to black. You know, there's still a tiny amount of pitting. Now it's my understanding that what's in the pitting is probably just paint, but it's worth being absolutely sure that we've got rid of any trace of rust, I think, before we paint it with Hammerite black paint. Now we won't be painting this top bit here, because that's where the rubber fuel outlet pipe will connect to. And it should be said that the rubber hoses that are on the car are not compatible with the junky petrol you get these days, the E10. So I have to buy E5, which is harder to source. So wait for 20 or 30 minutes and then apply a second coat.
Okay, so we'll just leave that for a while, and then I'll go over again in 20 minutes. And well, I'm debating amongst myself if I should sand it between coatings. I don't know. I think probably doesn't need it because it's pretty clean. It's not like it's got loads of rough rust still on there. It is actually turning surface black. I thought it would just turn rust black, but the whole surface is going black. It's been about 10 minutes now. So I've wiped it off this area because I don't want anything on there that could interfere with the way the rubber fuel hose connects to this. So being a bit cautious, I've wiped it off there. This area I will apply the second coat, and then I will paint it tomorrow with Hammerite black paint. Okay, some 20 minutes has passed, so it's completely black. I wasn't expecting that, but now we're ready for the next coat. Not sure this is necessary, but I will do that anyway. You tell me, what would you have done? Would you have just left it shiny steel colour and painted directly onto that, or would you have done this treatment? I could not possibly have got rid of every last tiny amount of rust in there, and so this is the only way to be sure that all the rust has been killed. What would you have done? Okay, so I'll leave that now. Well, my Hammerite paint's a bit dried up, but I think it will do actually. Right, from the point of view of cosmetics, it probably looked better before I'd done that, mainly because the paint's a little bit lumpy in places. But you know, it had a smoother finish with just the this treatment. But I think that's a much harder wearing surface, and I think also it'll flatten out somewhat as it dries. So hopefully by tomorrow that will be a finished job.